Hi everyone. Today we're going to go through some questions on atomic structure. Right, so let's look at the very first question. The successive IE of two elements M and N are given below. So from this table, right, you must be able to decide M and N are in which group. Right. So if you always look out for the biggest jump. Okay, look out for biggest jump, and I think if you look carefully, you'll notice that you have to find the difference, and you'll notice that this part here will show the biggest jump, right, from here to here. So there's a big jump from the second to the third IE, which means M is actually in group 2, right? It's actually in group 2 because it takes a lot of energy to remove the third electron. So the third electron must be from an inner shell, okay? So like the third electron, so 1, 2, 3, right? So this third electron is actually very difficult to remove. That's why there's a big jump from the second to the third IE, right? Okay, so this is what it means. Okay, so for N, let's look for the biggest jump again. So if you look at over here, you can see that there's a big jump from the 7 to 8 IE, so which means this is in group 17, right? So just imagine, just a quick one, imagine this was like a magnesium and imagine this was like a Cl, right? Then you think you know the formula is going to be like MgCl2. So which means in this case would be like Mn2, right? So that's why the answer is B. All right, okay, let's look at the next question. Which of the following statements best explains why the first IE of argon is higher than that of sulfur? Right, so if you look at the periodic table, you know that in the same period, right, sulfur, after sulfur, it will be chlorine, then argon, right? Sulfur, chlorine, then argon, right? So when you look at IE, right, you have to look at nuclear charge and shielding effect, okay? So nuclear charge and shielding effect actually helps to explain IE. So the answer for this question is actually C. I mean, some of you might be thinking, argon has a complete octet while sulfur does not, okay? Having a complete octet is just an observation. So normally those noble gases have a complete octet, which means they are actually quite stable, but that doesn't explain why the first IE is higher. So the first IE must still be explained based on nuclear charge and shielding effect, all right? So as you go across the period, as you can see from sulfur to argon, the nuclear charge actually increases, right? And the shielding effect, okay, nuclear charge increase of course because there are more and more protons. Shielding effect is approximately constant, all right, approximately constant, which means there's a increase in effective nuclear charge, right? There's an increase in effective nuclear charge. The valence electrons are drawn more closely to the nucleus. It requires more energy to remove the valence electron. That's why the first IE or argon is definitely higher than that of sulfur. All right, so the best answer is still C, right? C. All right, let's look at the third question. Okay, beams of charged particles are deflected by electric field. In experiment, protons. So protons are actually this, okay? Proton, I always say is a H plus, okay? H plus a proton, deflected by angle of 15. Another experiment, particle A is deflected by angle of -5 degrees. So angle of deflection is proportional to charge over mass, all right? So I'm just gonna write down for the particle A, right? Let's look at the charge over mass. This charge over mass for particle A over charge over mass for the proton, okay? Charge over mass, so the charge for proton is +1, the mass is 1, okay? So particle A is deflected by -5 degrees, proton is deflected by +15 degrees, right? So which means the charge over the mass, right? The charge over the mass, the charge over the mass of the particle A, I'm just gonna write here, is equals to -1/3, all right? So if you look out for something that the charge over mass is -1/3. Okay, so I'm gonna write down over here the charge. Okay, I put here E stands for charge, and I'm gonna put mass over here. So the charge, you can see, you just compare the protons and the electrons. So there's one extra electron, so there's -1. Okay, 2 electrons, 3 protons, so it's +1. 3 protons, 4 electrons, -1. 4 protons, 1 electron, +3. Okay, so if you look at the mass, you just sum up the protons and the neutrons. So mass is 3. For the second one, mass is 9, right? 3 plus 3 is 9. 3 plus 3 also 9, all right? And this 4 plus 5 is also 9. All right, so which one gives a charge over mass of -1/3? Actually, the answer is A. Can you see that? Here, okay, 1 divided by 3. All right, let's look at the next question, question 4. All right, Which particle on losing 2 electrons will have a half-filled p subshell? Alright, so normally what I do is I'm just gonna write down the configuration for gallium, selenium, thallium, yeah, actually that is what's that? Tellurium, okay, tellurium. Alright, and this is arsenic. Okay, so I'm going to write the configuration. I'm going to keep it really simple. I'm just going to write N as the outermost shell. So for gallium will be NS2 NP1, right? Because gallium is actually in group, go write down first. Gallium is in group 13, selenium is in group 16. Alright, tellurium is also in group 16, and arsenic is in group 15, right? So if N is the outermost shell, I'm just going to write down the configuration. NS2 NP4, okay, because there are 6 electrons in the outermost shell. So same for this, and this will be NS2 NP3, right? Because there are 5 electrons in the outermost shell. N represents the outermost shell. Okay. Okay, so they say on losing 2 electrons, we will have a half-filled p subshell. So on losing 2 electrons, it becomes more positively charged. Okay. So in fact, after losing 2 electrons, right, this one becomes Ga plus. Okay, after losing 2 electrons, this one becomes Se plus. All right, this one becomes, after losing 2 electrons, becomes Te3 plus. All right, and this one becomes, oh, after losing, it becomes 4 plus. All right, so I'm going to write the configuration for these over here. All right, so let's take a look. So for gallium plus, it will be NS2. For selenium plus will be NS2 NP3, right? For this will be NS2, lose 3 electrons, right? So NP1, and this will be 4 plus. 4 plus means NS1. Oh, there's no more p electrons. Okay, which one have a half-filled p subshell? Half-filled p subshell. So you can see that this is the one, NP3, right? So NP3 looks like this. 1, 2, 3. So this is a half-filled p subshell. So the answer for question 4 has to be B. Alright, okay, let's look at next question. Question 5. Okay, what's the likely formula of the compound between B and C? So the same thing, you look for the biggest jump to identify which group B and C will be in. Alright, so I can see that biggest jump is over here. Alright, so big jump from 6 to 7, i.e. This element is in group 16. Right? So the next one, let's look for the biggest jump. I think the biggest jump is over here. Alright, so from 3rd to 4th, i.e. this will be in group 3, or in fact 13. Okay, so maybe you just try the example. So think of an element that is in group 13. Alright, so maybe I think of polonium. Think of element that is group 16. I think of oxygen. So for example, you get Al2O3. Can you see that? So it should be like C2B3, right? So I'm just going to look for the one that is most similar, so that has to be B. Okay, let's look at next question. Question 6. Which ion, right, has less electrons than neutrons and less neutrons than protons? Okay, it's I think we have to try to find out. They have the neutrons here, so we're going to write down for protons as well as electrons, right? Okay, so we're going to do some calculation over here. Right, okay, so if I want to find number of protons, I take the nucleons. Nucleons is neutron plus proton. Okay, so in order to find the number of protons, right, I need to take the nucleon number minus the neutrons. Alright, so 37 minus 18, that will give you a number of, let me see, 19, is it? Okay, it's 34 minus 17, I guess it's 17. 33 minus 16 will be 17. 31 minus 16, it will be 15, right? So let's look at the number of electrons, right? So if it's a minus, right, it's a minus, it means that it will have one more electron than proton, isn't it? So this will be 20. X 2 plus, okay, 2 plus means it must have 2 extra proton compared to electron, so this electron will be 15, right? Got 17 here, so 15, 2 plus. So here will be 14. Alright, and 3 minus, so which means it must be 18, right? So let's look at what is the possible answer for this, right? So less electrons than neutrons, okay, less electrons than neutrons. Okay, I'm going to focus on neutrons and electrons, less electrons than neutrons. So I can eliminate this because this is 20 and this is 18, so that doesn't work. Okay, this one is possible. All right, just put tick here. Fewer electrons than neutrons. All right, here 15, here 17, here 14 and 16. Yeah, this is possible. 18 and 16 is not possible. All right, so you only have option 2 and 3. All right, so less neutrons than protons. Less neutrons than protons. Let's look at the neutrons. 17 proton. Oh, they are the same. So this one's out already. Okay, so this one's 16 neutrons and 17 protons. Yeah, so this is definitely correct. The correct answer. Okay, so 6 has to be Y3 plus. Okay, so the answer is C. Okay, let's look at next part. Okay, question 7. All right, which of the following graphs gives the correct trend for the first IE for the elements in period 2 and period 3? So you notice that for period 2, across a period from lithium to fluorine, all right, okay, across a period, you know that the general trend is going up. Okay, but there's always a bit of an anomaly. So I guess the trend is always going up because IE increases across a period, right? Okay, but you must notice there's always 2 anomaly over here. Can you see? The anomaly that shows a dip. So why is there a dip? All right, this one is actually NS2, and say for example, the first one here, maybe I just show you. This one is in group 2, so NS2 only. All right, so this one here, maybe I need more space. Okay, this one over here is actually NS2 MP1. So this electron is actually further from nucleus, so easier to remove. So that's why there's a dip. Okay, this one here is group 5 NS2 MP3, or group 15 in fact. This one here is group 16 NS2 and P4. So remember, MP4 means 1, 2, 3, 4. So this one is MP3, which is like that. Okay, so this one has inter-electron repulsion. So definitely easier to remove. That's why you also see a dip. All right. So this is the across after fluorine is neon. All right. So neon has the highest, and then after that it dip goes all the way down. All right. Why does it go all the way down? Because if you think about it, neon actually has a configuration of say 2, 8, right? And after neon, if you go the next row is actually sodium. So sodium is actually 281. So definitely this electron is much easier to move because it's of a different principal quantum shell. So you expect there to be long dip. All right, and then it starts to increase again. All right. Okay, so the answer actually will be B. All right. Okay, let's look at the next question, question 8. Chromium has 2 stable isotopes, right? So we need to again recall for chromium. Chromium, let me see, the proton number is 24. Okay, so if you remember for chromium, I want you to remember the configuration for chromium is the one that you have to memorize is the anomaly. All right. So chromium instead of 4s2 3d4, right, is actually the actual one is actually is not right. It's supposed to be 3d5 4s1. Okay, so this one you have to learn by heart. Okay, so let's look at the options. Okay, which of the following statement is correct? Chromium 2 plus ion has fewer protons than chromium 3 plus. So chromium is still the same element, all right? So wrong. They have the same number of protons because protons will define the element, right? So they should have the same number of protons. Okay, the configuration for Cr plus, okay, in fact, you have to remove from the 4s then the 3d, when it becomes a plus. So it's supposed to be 3d5, all right? Okay, not 3d4. It's 3d5 because you're taking away electron from the 4s. Okay, so this is also wrong. All right, B is wrong, A is wrong. Chromium 2 plus ion has the same number of neutrons as chromium 3 plus. In fact, the number of neutrons here is 52 minus 24, which is actually 27, no, so 28, sorry, 28. Okay, so 28 neutrons. Okay, for this one, number of neutrons is 53 minus the proton number, which is 24. So this is actually 29 neutrons. Okay, so they don't have the same number of neutrons, so this out. Okay, so answer has to be D. Okay, so chromium 2 plus has more unpaired electrons than chromium 3 plus. So I'll say chromium 2 plus, the configuration would be 3D. After taking away 2 electrons is 3D4. Okay, this one would be 3D, take away 3 electrons, right? So it would be 3D3. So let's try to draw 3D4. 1, 2, 3, 4. So there are 4 unpaired. This one will be 1, 2, 3, right? So this one 3 unpaired. So it's more unpaired electrons for chromium 2 plus compared to chromium 3 plus. That's true. Here it's 4 unpaired. Here has only 3 unpaired. All right. So that definitely the answer is D. Okay, let's look at question 9. Which of the following species will produce the largest deflection when fired with equal velocity in the electric field? So angle of deflection is of course proportional to charge over mass, right? So firstly you must calculate the charge over mass for lithium. So it's plus 1 over 7. This is plus 2 over 9, minus 2 over 16. This is minus 3 over 14, right? So you're going to press your calculator for the answers. Okay, let me just write it down. Okay, so this value is actually about 0.142. This is actually about 0.22, right? This one is actually equals to minus 0.125. This is in fact minus 0.214. So the one that shows the largest deflection, all right, we have the largest charge over mass ratio. So in this case, it should be B. Okay, so this is the largest charge over mass ratio. Okay, let's look at question 10. All right. Okay, use of the data booklet is relevant to this question. Right. So chromium atom again, the configuration is 3D5 4s1. So they say chromium atom has an empty d orbital. Okay, so it's not true because 3D10, 3D5 looks like this. 1, 2, 3, 4, 5. So it doesn't have an empty d orbital. Okay, so this is out. Right. All the electrons in the d orbitals of Mn2 plus are unpaired. So if you look at the configuration for manganese, all right, manganese would be, okay, it's supposed to be 4s2, then 3d5. Okay, 4s2, 3d5. Okay, but do you want Mn2 plus? So Mn2 plus would be 3d5. You take away from the 4s. So all the electrons in the d orbitals of Mn2 plus are unpaired. That's true. d5, all of them are unpaired like this. Okay, see? All of them are unpaired. So 2 is definitely correct. The Fe2 plus ion has the same electronic configuration as cobalt 3 plus. So let's look at iron. Iron actually has, let me see, how many protons? 26 protons. All right. How many electrons? There should be, you take away 2 electrons, right? So it should be 24 electrons. All right. Okay, because it's 2 plus. For cobalt, let's look at cobalt. Cobalt actually has 27 protons. So it's 3 plus, which means it has 24 electrons. So it seems that both of them have the same number of electrons. They should also have the same electronic configuration. Right, so the answer for this is 2 and 3. Okay, so that's for question 10. Okay, let's look at the next question. Right. The use of data booklet is relevant to this question. In which pairs do both PCs have different number of unpaired p electrons? Okay, so you need to write the configuration, right, for these elements. So Al, okay, Al actually has 3 valence electrons, but now since it's 2 minus, it would have actually 5. So I'm going to say the configuration should be Ns2 Np3. Okay, N represents the outermost shell. Okay, for aluminum. So O plus. Okay, oxygen actually has 6 valence electrons, but once you take away 1, right, it becomes 5. So it's actually Ns2 Np3. Right, so they have the same number of unpaired p electrons. Okay, see that? Okay, nitrogen. Okay, look at nitrogen. Nitrogen valence shell is Ns2Np3 because it has 5 electrons in the outermost shell. Okay, Cl actually has 7 electrons, but since it's 2 plus, it now will have also 5 electrons in the outermost shell. Okay, so I think Cl2 plus will also have the same configuration. All right, and always represents the outermost shell. Okay, let's look at carbon. Carbon is Ns2Np2 because it has 4 electrons outermost shell. All right, so Cl plus, right? Cl plus, Cl first. In fact, it should be Ns2Np5. Okay, 7 electrons. But since it's a plus, you have to take away 1. So now it becomes Np4. right? NP4. So let's look at NP2. Okay, so there are 2 electrons in the p orbital, p subshell. Here there are 4, right? So 1, 2, 3, 4. So if you look at it carefully, in which pairs do the both species have different number of unpaired electrons? In fact, this one has 2 unpaired and this one also has 2 unpaired. In fact, they still have the same. Okay, so let's look at the next part. All right, the last one, B minus. Okay, boron is actually in group 13. So minus means it probably has 4 electrons. So it looks like this, NS2, NP2. All right, in the outermost shell. Sulfur has 6 electrons, but it's a plus, so you lose 1. So now it only has 5 electrons in the outermost shell. So it's NS2, NP3. So NP2 looks like this, 1, 2. Of course, NP3, 1, 2, 3. So they have different number of unpaired p electrons. Say this one has 2 unpaired, this one has 3 unpaired. All right, p electrons. So the answer is D. Okay, let's move on to the next question. Question 12. Okay, which of the following statements are true? Okay, so this is alpha particle, which is helium nuclei, and then they show the lithium ion, right? So alpha particle is actually 4, 2, He2 plus. Okay, so which means this plate must be a negative plate because the particles are the lithium plus, right? Lithium plus is attracted to this side, so it must be negative, and this side will be positive. All right, so since this side is positive, X could be an electron. That's right, it could be minus. Minus will be attracted to plus. Okay, so this I'm going to put a tick here. True. Okay, plate Y is positive. Yes, okay, because since this plate is negative, the other plate must be positive. This is also true. The angle of deflection of alpha particle is 3.5 times the angle of deflection of lithium. So I'm going to put angle of deflection of the alpha particle, which is this, over the angle of deflection of lithium plus. Okay, so I'm just write down. So lithium is 7.3. Okay, so over here is plus 2 over charge over the mass plus 2 over 4, charge over mass plus 1 over 7. Can you see that? Over the mass. So this gives you a value of 14 divided by 4, which is actually 3.5. Okay, so you can see that it's true, the alpha particle is deflected 3.5 times more than the lithium ion. Okay, so this is also true, which means for question 12, answer is D. Okay, answer is definitely D. Got it? Okay, let's move on to the next question, 13. Which element has the largest atomic radius? So you have to go to your data booklet and look out for these elements. All right, and you must find out which period and which group do they belong to. All right, so I'm just going to say this. This is in period 4. You check the period table. Period 4, and it's of course group 17. Okay. Okay. How about IN? All right, IN is actually in. Let me see which period. 1, 2, 3, 4, 5. Okay, it's in period 5. Okay, I'm going to write down this is in period 5 and group 13. All right, so potassium is in period 1, 2, 3, 4, is in period 4. Okay, and of course group number 1. Okay, rubidium. Okay, rubidium is in 1, 2, 3, 4, 5. Okay, period 5 and group 1 also. Okay, so we know that the atomic radius actually becomes smaller and smaller, smaller, smaller across the period. So the largest one must always, of course, be in group period 5 first, because definitely. Okay, and then as you know that atomic radius decreases across the period, I believe that this one will be the largest and this one will be smaller, right? So in fact, they want the largest, right? So it has to be rubidium over here. Okay, that's how we do it. Okay, let's look at the next question, right? Which particle has more neutrons than protons and more electrons than neutrons? So no choice. Okay, maybe I'll just say this. If you look at the elements itself, okay, firstly they say more neutrons than protons, more electrons than neutrons. Okay, maybe we probably have to do it this way. I think you have to try to calculate for all of them. So protons, neutrons and electrons. Can? Okay, this is what it looks like. Carbon is like that. Okay, oxygen, right? So for carbonate, right? So carbon is number of protons are 6 plus 8 times 3. Okay, number of protons. Can you see that? So 8, 16, 24. This is 30. Okay, so maybe, oops, sorry. So I'm going to write down first. This is 30. All right. In terms of the neutrons, okay, so it has 7 neutrons for carbon. Right, 13 minus 6, 7. So 7 neutrons over here. And each oxygen also have 8 neutrons. So 8 times 3. All right, so this is 31. Okay, since it's 2 minus, there must be 32 electrons compared to 30 protons. Right, so NO2 plus. Okay, so there's 14, 7, 16, 8. Okay, so the protons again, 7 plus 8 times 2. So 16 plus 7, that gives you 23. Okay, the neutrons is 7 from nitrogen. Oh, it's the same, huh? Plus 8 times 2. Okay, so it's actually the same thing, 23. Okay, number of electrons, so since it's positively charged, it would have 22 electrons. Right, okay, next one, S2 minus. So sulfur, the proton number is 60. Okay, so it will have 16 protons, 16 neutrons, and since it's 2 minus, it must have 18 electrons compared to the protons. All right, so N2 we take it to be 14, 7, and a plus. So number of protons altogether will be 14. Neutrons altogether, so 14, and electrons, since it's a plus, I think it should have 13 electrons. Okay, so which particle has more neutrons than protons? I will eliminate this. This is okay. This is also eliminated. Oh, so actually, it's actually AUD. All right, more neutrons than protons. Can you see that? Okay, so that's how we do it. Here, I could have stopped at one. Stopped at A. All right. Okay, let's look at the next one. Okay, just make sure it's correct. More electrons than neutrons. That's neutrons. More electrons. 32 electrons. 31 neutrons. So it's correct. Okay. Yeah. Okay, let's check question 15. Isolated gaseous species have a paired electrons in at least one of the d orbitals and a fully filled 4s. Okay, what could be the identity? So copper actually is 3d10 4s1. So this one is the anomaly, you just have to learn by heart. So, and it has a fully filled 4s, which is wrong. It doesn't have a fully filled 4s. All right. Okay, Fe3 plus is actually, if you think about it, is Fe is supposed to be 3d6 4s2. So 4s2 then 3d6. But since it's 3 plus, you take away 3 electrons, is 3d5. All right, so it doesn't have any fully filled 4s since the 2 electrons were lost. So this is also out. Same goes for nickel. I believe nickel, for nickel, the configuration will be 1, 2, 3, 4, 6, 7, 8. Okay, it's 3d8 4s2. So if it's nickel 2 plus, you also lose the 2 electrons, so it's actually just 3d8, right? So doesn't have, so the answer has to be D. Okay, but strontium 2 plus, actually the truth is this, strontium 2 plus, right? Let's see, strontium, it actually 38 electrons, right? So actually the configuration is like that. Let me just write it out for you quickly. Okay, normally I remember this part has already 18 electrons. Then 4s2. Okay, 4s2 means 20, right? Then 3d10, 30. Then after that is 4p6, 36, and then 5s2. So if it's strontium 2 plus, it will have lost that 5s2 electrons. So it will still have a fully filled 4s. Okay, it will still have a fully filled 4s. Can you see that? So strontium 2 plus is just without the 5s2, right? So the 4s2 is still there, right? So that's why answer is D. Okay, let's look at the next question. Look at question 16. All right, what could it be the identity of element X? Okay, so you can see that this is a negative plate. All right, and they put phosphorus here. Okay, phosphorus actually has a charge of +1 for this ion, and the mass is actually 31, 15, right? So angle of deflection is actually proportional to charge over mass. Okay, the thing is both of them have the same charge, plus and plus. So in fact, phosphorus is deflected more and X is deflected less, right? X is deflected less. So actually what I'm trying to say is X is heavier than P, okay? So just look at the periodic table, which element is heavier than P, and if you look at it carefully, it's actually sulfur, okay? Sulfur. All the rest are lighter, okay? So sulfur is 3216, all right? So 32, you can see it's heavier already. Okay, so that's how we do it for X, all right? Okay, we don't care about the charge because the charge are the same, plus and plus. Okay, so we only look at the mass, and X is actually deflected less, so it must be heavier. Okay, all right. Okay, let's look at the next one. Question 17. Okay, you just have to put in the numbers and you can see what is X. Okay, uranium, the proton number is 92. Rubidium, the proton number is 37. Right, cesium, the proton number is 55. All right, so actually think about it, 37 plus 55 is actually 92. All right, and here's rate 92, which means it should look something like this. This should be 0. All right, and if you look at the numerator, 235 on this side, 235. Okay, let's add this part. So 235 is equals to 96 plus 135 plus the mass number of X, right? Okay, but let's see how it's done. Over here is how much? 231. Okay, 231. Okay, so 231, 230, so it must be plus 4, right? So since there's a 4 coefficient here, means the mass number here must be 1, because 4 times 1 gives you 4. You see that? So which means, what is this? Okay, the mass number is 1, but the proton number is 0. It means that it is a neutron. Okay, it is a neutron, right? Okay, let's look at the next question, 18. What are numbers of electrons and neutrons in this carbonate ion? Right, carbon here is 13,6, oxygen is 16,8, O3 2 minus. So if I look at the number of protons first, I want to look at protons first. So protons is equals to 6 plus 8 times 3, okay, which is 30. So since it's 2 minus, it must have 32 electrons. Okay, so I'm going to put it here. Okay, how many neutrons? Okay, neutrons, right? So this one, 30 minus 6 is 7. So 7 plus 16 minus 8 is 8. So 8 times 3. Okay, so this is 31. So it looks like the answer has to be D. Alright, so that's how we do it. Okay, let's look at the next question. Okay, let's look at question 19. Right, so lithium is actually, I will just write the proton number. This is 3, this is 12, this is 16. And for fluorine actually is 9, right, the proton number. So which have the same which PC have the same number of unpaired electrons as chlorine atom? So chlorine actually is the outermost shell. There are 7 electrons, so it's Ns2 Np5, so 7 electrons. So Np5 looks like this, 1, 2, 3, 4, 5. So it actually has 1 unpaired electron. Okay, so this has 1 unpaired electron. So which one of them has 1 unpaired electron? So lithium plus actually is, I'm just going to write the final configuration is just Ns2, right? It's supposed to Ns2 Np1, but okay, maybe I just write the full thing, right? So it's supposed to be 1s2, 2s1, okay, but because it has lost an electron, so it's just 1s2, okay. So Mg is actually 1s2, 2s2, 2p6, 3s2, okay. But since there's a plus, right, since there's a plus, it becomes 3s1, okay. Oh, 1. Okay, so oxygen is supposed to be 1s2, 2s2, 2p6, 3s2, 3p4. Alright, so the thing is, but it's a minus, so it becomes 2p5. Okay, 2p5. Right, fluorine 1s2, 2s2, 2p5. Okay, but since it's a minus, become 2p6. Okay. So it must have 1 unpaired electron, right? 1 unpaired electron. So definitely this one has a 1 unpaired electron, 3s1. Okay, how about 3p5? 3p5 looks like this. 1, 2, 3, 4, 5. So there's actually one unpaired electron. So this is definitely correct. 2p6, right? So there's no unpaired electron. So the answer must be 2 and 3. Okay, that's for question 19. Okay, let's look at the next one. Okay, question 20. Okay, the second IE for any element is always higher than the first IE. They say which of the following is correct. So yep, from X gas to X2 plus gas. Alright. Okay, so as you keep removing electron from a certain element, it becomes more and more positively charged. Right. So once it becomes more and more positively charged, it's actually going to be more difficult to remove the electron. So the second IE definitely will be higher than the first IE. Alright, so this is definitely correct, true. Alright. The Ionic size for sodium plus is the same as Al3 plus because they are isoelectronic. Even though they're isoelectronic, they have the same number of electrons. Al3 plus has 10, sodium plus has 10. But do you realize that aluminum actually has more protons? Okay, more protons, right? So because there's more protons, the 10 electrons are attracted more closely to the nucleus. Is Al3 plus is supposed to be smaller, all right? So it's not actually the same. So this is false, wrong. Okay, the removal of 2 electrons from chromium to form Cr2 plus is from the 3D. Now, when you remove electron, you always remove from the 4s first, all right? But for chromium, since chromium is 3d5 4s1, so if you want to form Cr2 plus, you need to take from the one from the 4s and one from the 3d. But they say that removal of 2 electrons is from just the 3d, which is wrong. Okay, so this is actually false. Okay, let's look at option number 4. So in fact, aluminum, all right, it will become Al plus, okay, then become Al2 plus, then become Al3 plus, and become Al4 plus. Okay, all right. So for silicon, okay, silicon is from Si, yes, right, silicon plus, all right, then silicon 2 plus, silicon 3 plus, all right, then silicon 4 plus. Okay, the thing is this, if you look at the configuration, in fact, this guy, aluminum 3 plus, has a noble gas configuration. That's right. So the configuration for actually Al3 plus is just like 2, 8. Okay, I'm keeping it simple. But the configuration for Si3 plus is actually 2, 8, 1. All right. So you realize that from here to here, all right, to remove one electron from Al3 plus to Al4 plus, you're removing from the second shell. Okay. But from Si3 plus to Si4 plus, all right, you're actually removing electron from the third shell. Okay. So because you remove a third shell, it's actually further from nucleus, all right, much further from nucleus. So it's definitely much easier, okay? So which means this one has a very high fourth IE, okay? So very, very high fourth IE. So aluminum atom would actually require more energy. So which means this is actually true, right? Okay, let's look at the next question. Which of the following ions would undergo the greatest deflection in an electric field? So the greatest deflection again is proportional to charge over mass. Alright, so I'm expecting to find one with a high charge and actually a smaller mass. Okay, so you can see from here, I'm going to pick those with a 2 plus, right? 2 plus, 2 plus, 2 plus, and this is just a plus. Okay, so I'm going to choose A, C, and D. And I need one that's a smaller mass. So the one that's smaller mass is actually this oxygen ion, right? 16 compared to 18. Okay, this is actually bigger because it's a molecule, right? So there's a greater mass. So this is actually the lightest. So which means it will have the greatest deflection. Okay, highest charge and the smallest mass. Okay, let's look at question 22. Right, which formula could represent the chloride of element R? So let's look at which this element R, which group does it belong to? So you look for the biggest jump. The biggest jump is for 1, 2, 3, 4, 5, the 5th to the 6th IE, right? So this element is actually in group 15, right? So 15 is probably something like phosphorus, right? Phosphorus. So in fact, I'm thinking that the answer should be C, because if you have to draw it out, it looks like that. Okay. And there are 5 electrons around phosphorus, right? So this is the dot and cross, and phosphorus PCl3, you can see from here it has a stable octet, all right? So that's why the answer is actually C. Okay, let's look at the next question. Okay, which option shows the correct number of protons, neutrons, and electrons in the bicarbonate? Okay, so let's do a quick count. All right. Okay, for carbon, right? Carbon is like 14 and 6, right? So which means there's 6 protons, 6 electrons, all right, and 8 neutrons. Okay, so maybe I'm just gonna calculate the number of protons first. Okay, for carbon, so see carbon, let me see for carbon, carbon there will be 6 protons. Oxygen, there are 3 oxygen, right? So 3 times 8, right? Deuterium is 2, 1, so use this plus 1, so altogether there will be 6 plus 24 plus 1, which means 31. Okay, so there will be 31 protons. Okay, if I look at the number of neutrons, okay, let's look at carbon. Carbon actually has 8 neutrons. Okay, write neutrons first. Carbon has 8 neutrons. Oxygen each has 8 neutrons times 3. Deuterium actually has 1 neutron. Can you see that? So that gives you 8 plus 24 plus 1. That gives you 33. All right. So I think this is the answer. All right. So this is a minus charge over here. So if there are 31 protons, there must be 32 electrons because of the minus. All right. So the answer is D. Okay, let's look at question 24. Which particle contains the most number of unpaired electrons? So for chromium is actually 3d5 for S1. All right. For copper, copper is actually copper itself is actually 3d10 for S1, but since it's 2 plus, it becomes 3d9. Right. Manganese actually is 3d. Okay, it's actually 4s2, 3d5. Tellurium, all right, tellurium, I'm just looking at the element itself first. 16, this is in group 16. So normally, okay, tellurium, I'm just going to keep it simple, is ns2, group 16, this is a tellurium 16, so mp4. So for manganese, it will be 3d5, 2 plus, manganese 2 plus, right? Take away the 4s, 2 electrons. So 2 minus means you have to gain 2 more, so this one becomes, okay, this is just Te, this is Mn, just don't get confused. Okay, so this one becomes ns2 np6, right? So the most number of unpaired electrons, this one doesn't have any unpaired. This one has how many unpaired? If you try to draw it out, you'll notice 1, 2, 3, 4, 5. So this is 5 unpaired. All right, 5 unpaired. This one 0 unpaired. Okay, 3d9 is like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's actually 1 unpaired. Okay, over here, in fact, you can see that actually there are 6 unpaired. Can you see that? There are 6 unpaired. So the answer will be A, the most number of unpaired electrons. Let's do a question 25. All right, which statement about electrons in a ground state of carbon is correct? So for carbon, it's actually supposed to have a configuration of, since there are 6 electrons, right? 1s2, 2s2, okay, 2p2, right? So occupied orbital of highest energy is spherical. No, it's actually dumbbell shape, right? So that's wrong. The occupied orbital of lowest energy is spherical, which is true. This is S. S is spherical, so this is answer already, right? Okay, there are more electrons in p orbitals than there are in all s orbital. In fact, p orbitals there are 2 electrons. S orbital there are 4 altogether. You can see 2 plus 2 is 4. Electrons are present in 4 different energy level. Okay, 4 different energy level. In fact, it's 3 different energy level because you have 1s, you have 2s, and you have 2p. Right, so it's not 4 but 3. Okay, so this is also wrong. Anyway, the answer should be B.
Thank you for watching the Twig Learning Center chemistry tutorial. I hope you learned something new. Don't forget to click the subscribe button so you'll be updated when new videos are posted.